You are sitting at a cafe, watching the world go by, and everything feels perfectly still. But the ground beneath you is tearing eastward at 1,670 kilometers per hour. What would happen if that furious spin just stopped? Here is the unsettling truth. Nothing would actually stop with it. Every tree, every building, and your own body would keep moving, launching forward at the speed of a bullet. Right now, as you read this, you are not still. You are hurling eastward at roughly 465 meters per second, a speed that makes a bullet look sluggish. That is the spin of our planet at the equator, a fact so enormous it feels like a trick. But what would happen if that motion simply stopped, not gradually but all at once? Imagine the quietest second of your life, followed by a force you cannot possibly brace for. The very ground would betray you, and everything not nailed down would become a weapon. Let's imagine that moment together, because your body's about to encounter a physics lesson it cannot pass. At the instant of the stop, your angular velocity of 7.27 times 10 to the minus 5 radians per second is ripped away. If the planet decelerates to 0 in 60 seconds, that creates a lateral acceleration, a sideways shove entirely separate from gravity. According to hyperphysics from Georgia State University, this force would make it impossible to stand at almost any latitude, save for the poles themselves. And in that first brutal second, the numbers get even more personal. Live Science reports that a person at the equator would experience an inertial force of 0.034 newtons per kilogram. For someone weighing 70 kilograms, that means being thrown with a force equal to 2.4 times their own body weight. You wouldn't stumble, you'd be launched. Now, let's make this terrifyingly concrete with a story, a fictional illustration built on these very formulas. Meet Nam, a 30-year-old man driving on a highway in Vietnam at exactly noon. When the Earth stops, his car does not. It keeps its forward motion, sliding at roughly 1,000 kilometers per hour, the rotational speed at his 20 degrees north latitude. His vehicle becomes a projectile tearing across lanes before slamming into a bridge with the force of a plane crash. This isn't a prophecy, it's just inertia doing its job. To truly grasp this invisible power, you can build a miniature disaster on your kitchen table. First, place 2 cups of water on a plastic tray. Second, attach that tray securely to a toy car. Push the car rapidly across a smooth, flat surface. Fourth, stop the car abruptly by blocking it with a thick book. Fifth, watch the water slosh violently forward, a tiny but perfect demonstration of inertia. Of course, the scale is minuscule compared to the 465 meters per second you're carrying right now, but the principle is identical. The universe doesn't care about your permission. It only cares about motion. Everything unanchored will keep going, including you. So the question you should be asking isn't if you can hold on, but what else is about to let go. You have probably watched the movies where the ground cracks open and buildings crumble as the planet shudders to a halt. But those films got the physics completely wrong. The real disaster is not a violent shake, but an instant, absolute stop that turns the world into a silent, horizontal storm. Hollywood told you that humanity would have time to react, but the truth is that the air itself becomes the weapon. When the Earth halts, the atmosphere keeps moving at over 1,670 kilometers per hour, which is faster than the speed of sound at roughly 235 kilometers per hour. That difference creates a continuous supersonic boom circling the entire globe, and no earthquake special effect has ever captured that terrifying reality. The energy required to break the planet in just 60 seconds is about 1 times 10 to the 29th joules, which equals the blast of more than 50 billion Hiroshima bombs exploding every single second. Compare that to a fighter pilot who endures 9 Gs for a few moments and passes out, but the lateral force here would crush every structure by over 100 times that limit. In 1755, the Great Lisbon earthquake struck at 9 in the morning on a holy day, and thousands of people ran to the riverbank for safety, only to be swept away by the tsunami 30 minutes later. That tragic error shows how human instinct fails completely in the first minute of an unprecedented catastrophe. The wind would tear skyscrapers from their foundations like paper, and the ground would not crack open dramatically but instead stay perfectly still while everything not bolted down flies eastward. Even the most fortified bunker deep underground would not survive because the acceleration acts on every molecule of the building itself. The fiction of 2012 and the core showed survivors crawling through rubble, but the real horror is that the air pressure alone would collapse your lungs before you could take a second breath. Every continent would face a wall of wind moving at Mach 1.4, and the sound alone would be enough to shatter eardrums and windows for thousands of kilometers. This is not a disaster you watch from a distance because the atmosphere is the delivery system, and it wraps the whole planet in a single, unending scream. The movies made you believe that the end comes with fire and explosions, but the actual apocalypse is a quiet, relentless rush of air that leaves no time for heroics. So the next time you see a film about the Earth stopping, remember that the real science is far more brutal than anything a director could stage. The atmosphere is not nailed to the ground. When the planet halts, every layer of air above it keeps surging eastward at nearly 1,670 kilometers per hour, as recorded by Universe Today in 2016. This is not a strong breeze, it is a planetary-scale wind that turns the sky itself into a weapon. The oceans hold roughly 1.335 billion cubic kilometers of water, and according to NOAA's 2022 data, that entire mass will slam toward the eastern shores of every continent, raise higher than 1.5 kilometers within minutes. Imagine a wall of water taller than any mountain you have ever seen, moving faster than a jetliner, and you still won't grasp the scale. To make sense of it, compare it with the tallest wave ever recorded. NOAA's Tsunami Library notes that in 1958, a colossal landslide in Alaska's Lituya Bay produced a wave reaching 524 meters, which stripped trees from slopes up to that height. The inertial surge from a stopped Earth could be roughly 3 times that figure, a moving cliff of seawater that would swallow coastal cities whole before their inhabitants even heard the roar. The water does not just crash inland, it also carves into the seabed. As it sloshes and pours toward one side of the ocean basins, the currents become so turbulent that they reach the deepest point on the planet, the Mariana Trench at 11,000 meters, as NOAA Ocean Explorer reported in 2021. No trench is deep enough to escape the chaos. Think about what a mere fraction of that force can do. In 2011, an EF5 tornado tore through Joplin, Missouri, with winds of 308 kilometers per hour, leveling the entire town and killing 158 people, according to NOAA. The inertial wind from our stopped planet would be four times faster than that, and there would be no basement, no bunker, no shelter anywhere on Earth that could withstand it. The air itself becomes a grinding sheet of force, ripping buildings from their foundations and hurling debris at speeds that turn every loose object into a projectile. You would not hear the wind coming, you would simply be gone. So when the rotation halts, the sky and the sea become one moving wall, and the eastern coast of Vietnam takes the horizon is no longer a line. It is a towering, churning front of water and air rushing towards you. And just when you think the surface is the only nightmare, the ground beneath your feet begins to tear apart. The inner core of the Earth is a solid sphere of iron and nickel, roughly the size of the moon, and it is surrounded by a liquid outer core. Within seconds of the crust halting, this vast molten heart of the planet continues to spin according to its own inertial momentum, completely out of sync with the stationary surface. This catastrophic misalignment between the lithosphere and the core creates unimaginable shear forces that tear through the planet's thin, fragile geological shell, triggering earthquakes of a scale never before witnessed. Consider this. The most powerful earthquake ever recorded on our instruments was a 9.5 magnitude event that struck Chile in 1960. The seismic slip between the crust and the core, however, would generate a succession of quakes exceeding 12 on the Richter scale, a force so immense it shatters every scale we have to measure it. What would those moments actually feel like? The ground beneath you wouldn't just shudder, it would fracture, heave, and buckle like a living thing in its death throes, turning stable bedrock into a chaotic, rolling sea of stone and dust. As the tectonic plates grind against each other under this unprecedented compressive stress, the entire Pacific Ring of Fire, a horseshoe of volatile fault lines, would erupt in a synchronized, planetary-scale volcanic apocalypse. The Earth's crust, stressed beyond its breaking point, would split open, and come from hundreds of volcanoes simultaneously, from the Andes to Japan, painting the sky black with ash. Simultaneously, the very shape of the planet would violently change, as the loss of centrifugal force at the equator causes the Earth's bulk to contract, shrinking the equatorial radius by roughly 21 kilometers. This sudden, massive displacement of mass would force ocean water to surge toward the poles with an unstoppable force, inundating high-latitude cities like Moscow within the first 60 seconds, completely drowning them before the seismic waves even arrive. And then there's the technology, the fragile network we believe makes us powerful. The Earth's magnetic field, our invisible shield against solar radiation, is generated by the dynamo effect of the rotating liquid outer core. As the surface stops but the core's rotation lags and destabilizes, the field would weaken dramatically, allowing solar radiation to penetrate deep into our atmosphere and fry electronic circuits worldwide within the very first minutes. As if that weren't enough, physicists at MIT have shown that the sudden deceleration of the crust against the sloshing liquid core would induce massive electrical currents, powerful enough to overload and destroy the entire global power grid through electromagnetic induction. High-voltage transmission lines would melt, substations would explode, and in a flash of light, the world would plunge into a darkness darker than any night in human history. A darkness where the only light comes from fires and volcanic eruptions. This cascading catastrophe, from the planet's core to the silicon chips in our devices, proves that the annihilation is total, complete, and utterly inescapable. Your inner ear is the first casualty. The vestibular system, deep inside your skull, relies on gravity to tell you which way is up, and the sudden loss of centrifugal force scrambles that signal completely. Your brain receives conflicting data from your eyes, your joints, and your balance organs, and the horizon itself becomes a meaningless concept. The ground no longer feels solid beneath you because your body is still trying to process a motion that has just vanished. Blood rushes to your head or pools in your legs as the normal pressure gradients that your cardiovascular system depends on are violently disrupted. The change is not gradual, it is an instantaneous, brutal redistribution of fluid, and your body has no time to compensate. At this point, your lungs face their own terror. The standard atmospheric pressure at sea level is 1013.25 hectopascals. But as the air itself becomes a supersonic weapon, the pressure at converging points can plummet to levels found inside an EF5 tornado. This sudden drop isn't just uncomfortable, it can cause the air sacs in your lungs to rupture from the inside out. Consider the story of Captain Chesley Sullenberger on US Airways Flight 514 in 2009. When both engines failed, he had just 208 seconds to make a decision that would determine the fate of 155 souls. In that compressed window, his mind was not calmly calculating probabilities. It was a torrent of fragmented thoughts, adrenaline, and raw instinct. That is exactly what those first 60 seconds would feel like on a planetary scale, except your decision will not matter. There is no river to land on, no heroics that can save you. To truly understand your own helplessness, try this thought experiment. First, write down your current location, your exact longitude and latitude on a piece of paper. Second, go online and calculate the rotational velocity at that specific point. You will be shocked by the number. Third, decide where you are in that moment. Outdoors, inside a basement, or on the top floor of a skyscraper. Fourth, apply the simple formula, force equals mass times acceleration, to estimate the force your body would experience if the planet stopped in 60 seconds. Fifth, compare that number to what your body can endure. For perspective, a knee joint shatters at just 2 Gs of force. Sixth, and finally, reach the only possible conclusion. No matter where you are, no matter how strong you think you are, the inertial force will turn your own body into a projectile. And here is the terrifying punchline. You will not even have time to understand what is happening. Your conscious brain processes threats on a delay, so you will be thrown, crushed, or suffocated before the first coherent thought even forms. The most sophisticated machine in the known universe, the human body, will be rendered obsolete in less time than it takes to blink. To grasp the sheer scale of the catastrophe, we have to look at how other worlds meet a similar fate. Consider Venus, a planet where a single day stretches longer than its entire year. The European Space Agency's Venus Express mission confirmed that it takes 243 Earth days for Venus to complete one rotation, making it the slowest spinner in our neighborhood. Yet Venus didn't stop abruptly, it slowed gradually over eons, allowing its thick atmosphere and hellish surface to reach a kind of equilibrium. Even with its crushing pressure and acid clouds, the planet remains intact as a world. The difference between that gentle deceleration and our hypothetical stop is the difference between a slow leak and a dam bursting. When a planet halts in an instant, every system that relied on that motion rebels at once, and there is no time for the pieces to settle into a new balance. So, what does a sudden release of energy look like when we have a real historical yardstick to measure it? Think back to the eruption of Mount Pinatubo in the Philippines in 1991. When that volcano blew, it ejected 10 billion tons of magma into the atmosphere, a blast that lowered global temperatures and triggered a cascade of earthquakes and lahars that reshaped the surrounding landscape. It was one of the most powerful volcanic events of the 20th century, and it was felt across the entire planet. But here is the uncomfortable truth. That entire eruption, with all its fury and its capacity to alter the climate for years, represents a speck of dust next to the energy needed to halt the Earth's spin. The momentum stored in the planet's crust, its oceans, and its churning interior is so vast that all the volcanic power ever recorded would barely make a dent in it. If the Earth were to stop in 60 seconds, the energy released would not just dwarf Pinatubo. It would make that famous eruption look like a firecracker in a hurricane. The comparison isn't even close, and it forces us to realize that our familiar disasters are simply too small to prepare us for this. We can also look to a tragedy that shows how a sudden surge of force can turn infrastructure into a weapon. In 1989, a leak in a natural gas pipeline near Ufa, Russia, created an invisible cloud of fuel that was accidentally ignited when 2 trains passed through the area, producing a blast that killed 645 people. The explosion was so violent that it flattened entire sections of forest and was felt over 100 kilometers away. Now, imagine that same principle, a sudden release of stored energy along a vulnerable line, applied to every pipeline, every power line, and every fuel tank on Earth within the first minute of the planet's stop. The liquid in the Siberian pipelines, for example, would not stay still. Driven by inertia, It would slam against the pipe walls with the force of a solid projectile, rupturing the metal and igniting fireballs along thousands of kilometers of track. History shows us that even a small, contained break can kill hundreds. So what happens when every line fails simultaneously? Every comparison we make, whether to volcanoes or explosions, only underscores the terrifying truth. No historical event anywhere near matches the scale of what a sudden stop would unleash. In the heart of the chaos, one of the most unsettling truths is that the very laws of physics, which seem to betray us, remain utterly indifferent. Think of the Foucault pendulum, the famous device hanging in the Musée des Arts et Métiers in Paris since 1851, which proves our planet rotates. If the Earth halted in an instant, that pendulum would not stop. It would keep swinging, a serene testament to the fact that motion is never destroyed, it simply changes its frame of reference. We are the ones who get torn apart, but the pendulum, and the universe it represents, just continues its eternal dance. This sudden loss of spin would also violently reshape the planet's very form, because Earth is not a perfect sphere. It is a bulge at the equator, a shape held by centrifugal force. When that force vanishes, the equatorial bulge collapses, and the waters of the oceans, along with the viscous mantle rock, would surge toward the poles. The sea level at the equator would plummet, while the polar coastlines would be drowned under hundreds of meters of water in a geological instant. The world map, would be redrawn in minutes, not millennia, and the scale of this redistribution is almost impossible for the human mind to hold. Yet even in this apocalyptic moment, the globe itself would be reeling from a more subtle, ghostly motion. NASA's Jet Propulsion Laboratory has confirmed that even under normal conditions, our planet's rotation axis wanders, drifting up to 9 meters every year in what is called the Chandler wobble, influenced by climate factors. A sudden stop, however, would send that wobble into a violent, uncontrolled lurch, making the very orientation of the planet in space unpredictable. It is a stark reminder that we are not standing on solid ground, but on a spinning top giggling through the cosmos, and once that spin is broken, the top begins to die. But here is where you can actually check the terrifying math for your own street, and it is a simple process of discovery. First, open up Google Earth and type in the phrase Earth rotation speed at latitude to see the model. Then cross-reference that data with a tool like Wolfram Alpha, and for a city like Hanoi, you will find the ground is tearing eastward at roughly 560 kilometers per hour. Next, go to Google Scholar and pull up a NASA paper on Earth rotation rate variation, noticing the distinction between angular velocity and the linear speed we feel on the surface. Finally, look at the longitude and latitude for your exact house, and you will realize that the force of destruction depends entirely on where you stand. This is the irrefutable proof that the catastrophe is not equal for all, and that the physics dictating our doom is written in plain sight. What is truly mind-bending is that this maelstrom of vorticity, this global tornado, is stronger than an EF5 twister in a regular storm, yet it is only a byproduct, a detail in the 60-second apocalypse. The air, racing 5 times faster than the most powerful hurricane ever recorded, would generate shear forces that spawn colossal, planet-wide tornadoes, tearing the atmosphere to shreds. But even as the world ends in a screen of wind and water, the deeper truth remains. The universe does not stop, and the laws that govern the dance of galaxies and the swing of a pendulum in a quiet Parisian museum are completely unconcerned with our desperate need to hold onto the ground. 60 seconds. That is all it takes to erase thousands of years of human achievement. Not hours of gradual decay, but a single minute of violent, physics-driven unraveling that no bunker, no mountain, and no plan could possibly survive. The civilization would simply cease to exist, scattered by the very momentum that built it. And what would be left behind is not silence, but a planet fundamentally reborn without us. If the rotation stopped completely, a single day would stretch to exactly 3 and 65.25 of our current ones, according to NASA's Earth Observatory. But before that endless sun could bake one hemisphere, the razor-thin line between day and night would race across the ground. Like a shockwave, every city on Earth would experience a manic, accelerated twilight, a bizarre strobing of light and dark, as the tornado line tore across continents in minutes, not hours. Yet, amid this total catastrophe, something remarkable would persist. The Foucault pendulum in Paris, a device that has swung since 1851, would still arc back and forth, indifferent to the chaos around it. Its motion proves that physics itself does not care about our planetary fate. It simply follows its own immutable rules. The universe would continue its grand, silent dance, utterly unbothered by the extinction of the audience on one small blue rock. But here is the deepest mystery, one that physicists at Caltech we cannot fully grasp. There is still no computer model that can perfectly simulate this event because the interaction between the atmosphere, the oceans, and the rocky crust is simply too complex for our equations. Our most brilliant minds can only offer a rough estimate of destruction, not a precise answer. Reminder that some forces are still beyond our complete understanding. Think back to that coffee cup sitting perfectly still on your table while hurtling through space at 465 meters per second. It is now shattered, along with everything you've ever known. So, imagine yourself standing in that final second, feeling the ground lurch beneath you, and consider a strange truth. Be grateful that our planet still spins, because the alternative is a silence we were never meant to hear.